All right, so number 22, choose the correct statement. So that would be B. A combination is a group of items when order does not matter. 23, determine whether the following is a permutation or a combination. So medical researcher needs 8 people to test the effectiveness of an experimental drug. 32 people have volunteered for the test. And now, how many ways can these 8 people be selected? All right, do we care about order? No. And that's what it's going to go on to say. So the problem involves a combination because the order does not matter. Okay. All right. Number 24. You volunteer to help drive children at a charity event at a zoo. You can only fit 6 of the 20 children present in your van. How many different groups of children can you drive? All right, so we did do this one. When we do the videos for each section, it's easy to know how to do it because you're given the section, and then in 11.3, we knew how to do problems. But on the test, you're not going to know, you're not going to be given much information, so you have to figure it out. Now, with that said, if you read through the practice test enough and you see this question enough, you'll say, oh, zoo, children, van, combination. Okay, so that's fine too. But just still make sure you read through it because some are kind of similar, but they will work differently. So 24, we volunteer to help drive children to an event. 6 of the 20 children can fit in a van. I'm going to just work it right here. We got a total of 20. 6 can fit in the van, so 20. We know it's combination. I'm going to type that directly in the calculator. By now, you should know where that's at. So work it out, pause this. Let's see if we get the same number. Okay, that's what I got. Number 5, in how many ways can a committee of 3 men and 2 women be formed from a group of 7 men and 9 women? So I believe this one was in 11.123 combination homework. It may have been in 11.3, but I do remember doing a video for this one. But let's see. We got a total of 7 men, and we want to choose 3 of those men. And we have a total of 9 women, and we want to choose 2 of them. So here's what we got to do. This is like a combination involving combinations. Let me show you. We want to choose some men for the group, and we want to choose some women for the group. I'm working it like it's a blank problem, and that's because I need to first choose my men or women, doesn't matter, but I've got to choose one of them first. I got 3 men, but a total of 7 men. So 7, choose 3. Do the same thing with women. 9, choose 2. All right. So you could type this at once in your calculator, but I'm going to do these individually. I'm going to first do 7, choose 3 for the men. I get 35. And now I'm going to do 9, choose 2 for the women. I get 36. Okay, again, do these by yourself. See if you're getting these values. But I got this. That's my total ways to choose And I do remember seeing that one in 11.123 combination section. All right, number 26. In a race, which of the 7 automobiles are in a race? Which 7 automobiles entered? Oh, sorry, I forgot this word. The sentence didn't make sense. In a race in which 7 automobiles are entered and there are no ties, how many ways can the first 3 finishers come in place? Okay, so this is a similar question as choosing like president, vice president, treasurer, secretary, treasurer. I could do this with permutations. I could do this with my blanks. So I could say the first 3 finishers, blank, 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 first, second, third. If I have 7 automobiles, then I have 7 that could come in first, 6 that could come in second, and 5 that can come in third. So 7 times 6 times 5 is 210. Now, if you recognize this as a permutation, you could do 7 permutate 3, since I want the first 3 finishers, and I would also get 210. That's 26, 27. All right, electronics store receives a shipment of 40 graphing calculators, including 5 that are defective. I'm just going to write this stuff down. 40 graphing calculators. 5 are defective. 4 of the calculators are to be selected to be sent to a local high school. The question is, how many of these selections will contain no defective calculators? Okay. So if I throw away or just put away those 5 defective ones, we've got 35 non-defective calculators. This is what I want to choose from. So 35, choose. 4 of them are going to a high school. 4 are being selected. So 35, choose 4. 52, 360. Okay, that's how many I could choose from. All right, we'll wrap this video up soon. Yeah, we'll go ahead and stop the video there. The next one, number 28, is probability. So let's stop the previous video. That way we got through 11.1, 2, and 3. And we'll pick up right there with probability.